Alright, so for A1, what do the examples in each group below have in common? For group 1, we said, for A1, we said it's the same in each group with different signs. Because the equation is the same and it has the exact same numbers, except it just has a different sign for each one. Do you want to? And then for A2, we said, for A2, find the products in each group above. So 4 times 3 equals 12. 5.1 times 1 equals 5.1. And 3 times 4.5 equals 13.5. So that's the end for group 1. For group 2, 4 times negative 3 equals negative 12. Negative 5.1 times 1 is negative 5.1. And 3 times negative 4.5 equals negative 13.5. And then for group 3, negative 4 times negative 3 equals 12. Negative 5.1 times negative 1 equals 5.1. Negative 3 times negative 4.5 equals 13.5. And then for number 3, for A3, it said to write and solve 2 additional problems for each group. So for group 1, the pattern was a positive multiplied by a positive. So we just did 7 times 2 equals 14, and 5 times 7 equals 35. And then for group 2, what you would do is you would take the exact same equation as in group 1 and then add a negative to it. Like change one of the numbers to a negative. So we did negative 7 times 2 equals negative 14. And then 5 times negative 7 equals negative 35. And finally, for group 3, you're supposed to change every integer to a negative. So negative 7 times negative 2 would equal positive 14. And then negative 5 times negative 7 would equal positive 35. Now it's time for B.
So for B, you have to find the products in each group below is multiplication commutative. So 2 times 3 and 3 times 2 equals positive 6. Negative 2 times negative 3 and negative 3 times negative 2 equals 6. And negative 2 times 3 and 3 times negative 2 equals negative 6. So C.
What is with your Mr. Frankie, what if we didn't solve all of them?
That's okay. So you're going to explain what you've got, okay?
Oh, but we only have A.
For C1, the question.
Go straight to D.
Oh, all right. So D1. Oh wait.
Okay, for D1, the product is going to be positive. So 7 times negative 8 times negative 3 equals 165. Then for D1B, the product is going to be positive because negative 12 times negative 5 times negative 4 equals 1,440. And then for DC, half times negative, the product is going to be positive. And so a half times negative 2/3 times 3 equals whatever it equals. But it's going to be positive. And then for D2, explain how you used what you know. What? Negative. Yep.
Positive.
So it would be what? So
You've done one investigation. That is what you're responsible for. One investigation. The other group is supposed to present their work to you. At the end of this class, you should have
Hello, Tacola.
2 sets of algorithms, one for division, one for multiplication. That's the idea of this class. You need to copy down what would you like to do.
Give us 1 second.
You're only responsible for one investigation.
Okay, so, alright, so we'll start right now. This is Owen and Clark. And so the first problem for A1, problem 3.3, is -6 times -13. And so if you multiply numbers with the same sign, it doesn't matter if it's positive or negative, it'll come out a positive. If you multiply them with switch signs, say number 3 with, oh no, that's a bad example. Number 4, 8 times -6, it'll always be negative. So we'll start. -6 times -13 would equal 78. So if you just do positive times positive, and then, yeah, and then that's 78. So -2, which is 6 times -13, since the signs are switched, it would be negative, so it'd be -78. And then for 3, x times -9 equals 108. We want to know, so we could just say that if you multiply them by positive, say 12 times 9 equals 108. So that would work. So it'd just be negative. And then for the last one, 8 times x equals -48. Since the signs have to be switched, it can't be positive, so it has to be negative. So you would do 8 times -6 equals -48.
Alright, so for C, it says, what do the examples in each group have in common? And we only got as far as solving the answer for all the groups. So for group 1, the first question is 12 divided by 3 equals what? 12 divided by 3, as you probably know, equals 4. And then 4.5 divided by 9 equals 1/2. And then 2 1/4 divided by 1/2 equals 4.5. For group 2, so when you divide one positive and one negative, you get a negative number. So 12 divided by 3, no, 12 divided by -3 would equal -4. And -4.5 divided by 9 equals -0.5. Sorry. And then 2 1/4 divided by -1/2 equals -4 1/2. Because if you divide two numbers, if you divide two numbers with different signs, you will always get a negative number. But if you divide two signs with the same number, two numbers with the same sign, you will always get the same. Well, you always get a positive sign. So -12 divided by -3 equals 4. -4.5 divided by 9 equals 1/2. And -2 1/4 divided by -1/2 equals 4 1/2. So the algorithms for dividing numbers is if you divide two numbers with the same sign, you get a positive. If you divide two numbers with different signs, you get a negative. Alright, bye. How do you end this?
So the last thing, Tacola, that we talked about was...
The board's not magnetic.
No, the board's not magnetic. Sorry. Thanks, Clark. I got it. So the last thing we talked about is the connection between the algorithms for multiplication of integers and the division of integers. And we found out that when you have a positive times a positive, it equals a positive. But also, when the signs are the same, when you have a negative times a negative, it also equals a positive. If we have a positive times a negative, or in other words, when the signs are different, we ended up with a negative number. And when we have a negative times a positive, we ended up with a negative number as well. So when the signs were the same in multiplication, we got a positive product. When the signs were different, we ended up with a negative product. Then, when we looked at the division algorithms, we found that these rules also hold true for division. So if you know the algorithms for multiplication, you also know the algorithms for division. So that's what we got through today. Tomorrow, we are going to play the integer product game, which is kind of a fun game. It's a 3.4. My suggestion for you, Tacola, is to play it with, if you can't play with a classmate, play the game with your mom, which would not be a bad idea. Your homework will be on Edmodo, so please check the Edmodo site. I hope everything's well in California. Talk to you tomorrow.